Hello guys, welcome back to lecture series on discrete mathematics. Here guys, in our today's video, I'm gonna explain to you all mathematical induction and the principle of mathematical induction. Principle of mathematical induction is very important. You will get the question, explain principle of mathematical induction directly, okay, for the 5 marks or maybe for 3 marks. So you supposed to explain how the principle of mathematical induction works, okay. It is very important guys, okay. So without further ado guys, let's get dive into our today's lecture. I'm going to explain to you all first of all what actually the meaning of principle of mathematical induction and why it is needed, why it is necessary, okay, in mathematics. And then thereafter we go for the detailed understanding of principle of mathematical induction, okay. Yes, what actually the meaning of a principle of mathematical induction, okay. To check validity of a statement whenever we pronounce some statement in mathematics, that's supposed to be that's supposed to sound logically, okay. That means the sound mathematical statement need to be a sounds logically, okay. So in order to prove the logical soundness for this statement, we need a mathematical induction, okay. So we prove how this statement mathematically works, okay. Anywhere you go guys in research or anywhere, you have to prove this statement mathematically sounds, okay. Yes, so mathematical induction is a powerful technique in applied mathematics, especially like a number theory, okay, mostly used in a number theory, where many properties of natural numbers are proved by this principle of mathematical induction, okay. Now let me explain how the principle of mathematical induction it works, okay. So I'll explain principle of mathematical induction in a short step. So you can take this 4 short step and then explain it into your exam, okay. This one is quite easy, okay. So principle of a mathematical induction majorly divided into the 4 part, okay. Majorly divided into the 4 part. First is a foundation. First is a foundation, okay. Second is a succession. Sorry, second is assumption. Second is assumption. Third is a succession. Foundation, assumption, succession, and fourth is a induction. Okay. So this one is divided into this principle of mathematical induction, which is divided into these 4 part. So which also we called it as the FASI rule, okay. So you can remember very easily using this FASI rule, okay. F means foundation, A means assumption, S means succession, I means induction, okay. This one is a FASI rule. This one is very easy guys. So if you are able to remember these 4 different words, you can write very easily principle of mathematical induction, okay. First, foundation. Foundation means what we do for the mathematical statement, okay. First of all, I consider the mathematical statement, okay. I consider P of n be the mathematical statement. It is like f of x, like we consider f of x as x square plus 1 or something, any polynomial type example, okay. So such a for to verify such a example, we use mathematical induction too, okay. So instead of f of x, I have considered P of n as a mathematical statement, okay. Yes, so P of n, it should be the mathematical statement. Now in order to verify P of n is mathematical sounds, first of all we have to prove the foundation, okay. In the foundation statement, what we do, we put some natural numbers, okay, but natural numbers which is smaller than n, okay. So in our foundation step, in our foundation step for the P of n, for P of n mathematical statement, okay, we consider n as a smallest positive integer like a 1, or you can take 2, or you can take 3 or smaller element, okay. For all n should smaller than capital N. Okay, capital N means it is a natural number. Okay, these all N's should smaller than natural number. Okay, so this N's are smaller than natural number. Then we replace these random values into our given statement P of N. So for to prove foundation. Okay, so you replace P of N, P of 1, like a P of 1, like a P of 2, like a P of 3, and then so on. Replace these values into the P of N and find it out whether it mathematically sounds or not. Okay, this proves the foundation. Yes, so I hope you all have understood. Foundation means what? Foundation means put N which is equal to, what is meaning of foundation? Put N which is equal to 1 comma 2 and so on. Okay, and all N smaller than capital natural number N. Okay, yes. Okay, all this is all symbol. Okay, all N smaller than N. Now we understood here what is mean by foundation step. Okay, now we have next one after this success assumption. Okay, so we go for P of N to be proved by assumption. Okay, next what actually means meaning of assumption? Assumption means we assume something here. Assume means we have to consider, we suppose something. Okay, assume. Okay, we assume something. So in order to assume something, we consider something some of the random natural number. Okay, like P of N sounds mathematically with some value k. K should be smaller than natural number. Okay, okay, that means k should be something like a natural number. Okay, yes, we here replace assume k which is smaller than natural number N. Okay, we only assume in the assumption, we do not prove anything. Okay, so we assume k is smaller than natural number and we replace into the P of N as a k. Okay, that means we prove for we assume for the P of k here. Okay, yes, so in under assumption statement we assume, what we do in assumption, assume k smaller than natural number. Okay, assume k smaller than natural number. Okay, we into the assumption. Okay, then succession, we go for the succession. Next step, here only we assume for the P of k is smaller than natural number and we replace into the P of N, so it will be the P of k. Okay, yes, now then succession. In the succession step, guys, what we do, we prove. What we prove? We prove here our statement hold for some bigger value than k. Okay, some bigger value than k, so we consider k plus 1. Okay, P of N holds for some k which is smaller than k plus 1. Okay, that means we replace P of N as a N which is equal to k plus 1. We replace N as a k plus 1. Okay, so then we get it is the pk plus 1. Okay, yes. So first we assume P of k. This one is our assumption. This one is assumption. Here we made that one. Then we prove. Then prove P of k plus 1 holds. Okay, first we assume P of k hold and then we prove P of k plus 1 which turn out to be our required proof. Okay, then assume k is smaller than natural number and we use P of k. Okay, yes, by assuming P of k we succeed under succession step, we prove P of k plus 1 holds. Okay, and at the induction stage, induction means what? Under induction means conclusion. Okay, induction means we call it as the, we call this one as the conclusion also. For the induction we call the conclusion also. Okay, So don't get confused. Induction and conclusion both are the same mean word. Okay. Yes. So for the conclusion, that means whatever you proved into the succession, so you have to conclude into the one statement. Okay. That means our statement holds. What we can conclude? Our statement holds for p of k plus 1. Okay, our statement hold for p of k plus 1. Okay, this one is our induction. Okay, I hope you all have understood, guys. Okay, so we learn mathematical induction into the fourth step. Okay, induction means we conclude. Conclude means whatever we done into our 4 steps, that we conclude at the end of the proof. Okay, yes. For in our foundation we use 1 to n as the numbers. Okay, for the foundation, then we assume some k smaller than natural number, then we go for the succession p of k plus 1. Okay, first of all we assume p of k, then we prove p of k plus 1, and the whatever the proof it is coming in a p of k plus 1, we conclude, or we give the conclusion here or induction that our statement hold for p of k plus 1. Okay, this is our principle of mathematical induction. So we use FASI, we use FASI rule. Okay, we use FSI rule. I hope you all have understood, guys. You will get the question in your question paper. Write down the principle of mathematical induction. So you supposed to explain these 4 steps. Okay, for 5 marks. For your understanding, you can note it down. These my short points. Okay, maybe these are helpful for your in sem exam. Note it down, pause the video and see these ones. Okay, I hope you all have understood my today's lecture, guys. Okay, even after, guys, if you have anything difficulty, confusion, let me know in my comment section. For recording single videos, guys, it's need lots and lots of the challenges. Okay, yes, I hope you all have understood everything that we required for our principle of mathematical induction. Okay, so in our today's videos, guys, I'm gonna explain to you all some of the example which is very much important for our in sem exam. Okay, I will explain to you in our today's lecture. Okay, so tomorrow's lecture, I hope everything we have taken you all have understood. So that's it for our today's lecture. So thank you everyone, thank you for my today's lecture.